Welcome to The Explainer. Today, we're tackling a big one. How do you get your AI from a developer's laptop out into the real world, without breaking everything? We're talking about doing it safely and reliably.
So, how do you launch new AI without risking your entire business? This is the question, right? And look, the answer isn't just be careful. It's about having a disciplined, automated, and truly battle-tested process.
Okay, first things first, you've got to build a solid foundation. So let's dive into Section 1, automating the assembly line for your machine learning models.
All right, so what are we really talking about here? It's MLOps CI/CD. The goal is pretty straightforward, but honestly, it's a game changer. It's about automating everything, the building, testing, training, and deploying of your models with absolutely zero manual steps. The idea is to get rid of human error and create this super reliable path from a pull request all the way to a live service. So what does that pipeline actually look like? Well, picture this. Every single time a developer commits new code, it kicks off this whole chain reaction. It's a sequence of super rigorous, automated checks for everything, from data validation to making sure the model itself hits our quality standards. And this isn't just theory, okay? This is code as proof. What you're seeing here is a real snippet from a GitHub Actions workflow file. That little bit of code right there, that's what makes it all happen. A simple git push to the main branch is literally all it takes to kick off the entire process. It's automation in action. Now, this whole process, it isn't just about going fast. It's about being safe. These are our key quality gates. Think of them like automated security guards. We have these hard-coded rules that say, for example, if test coverage isn't above 98%, or if the model's AUC, that's a key performance metric, is below 0.94, it gets stopped, dead in its tracks. A bad model can never make it to production. And the result of all that automation? Well, here it is, 12 minutes. That's it. That's the time it takes for a new model version to go from a developer submitting a pull request to being fully tested, validated, and live in production. Just 12 minutes.
Okay, so your model aced all the offline tests. That's awesome. But here's the real question. How's it going to handle live, unpredictable, real-world traffic? That's what really matters. Which brings us to Section 2, testing in the real world.
So to figure that out, we use two really powerful validation techniques. First, there's shadow testing. Think of it like a perfect dress rehearsal. The new model gets live traffic, but we only log the results. There's zero user impact. Then you have canary deployment. This is where we get brave. We serve live traffic to a tiny percentage of users, say 5%, to see how it performs in a limited-risk real-world test.
And we're not talking about a few test runs. Before even thinking about a full rollout, this new model was put through its paces. It made over 1.2 million shadow predictions against live traffic. Why so many? We needed enough data to be absolutely sure with statistical significance that it was actually better.
And what did all that data tell us? Well, the numbers don't lie. We saw a 2.3% lift in performance, a clear improvement, with basically no negative impact on latency or the error rate. This wasn't a gut feeling. This was hard data giving us the green light to move forward.
So, with shadow testing done, we don't just flip a switch and send it to everyone. No way. We do a careful, gradual canary rollout. It starts with just 5% of traffic. We watch the metrics like a hawk. Everything looks good? Okay, up to 25%. Monitor again. Still good? Then, and only then, do we go to 100%. It's all about minimizing risk every step of the way.
But let's be real. What happens when, despite all of this testing, something still goes wrong after you launch? I mean, it happens. This is where a truly mature, production-grade system really shows what it's made of.
The answer is an automated safety net. This is a system that is always watching. It's continuously monitoring live performance against our goals, our service-level objectives. If it spots a problem, like latency spiking or accuracy dropping, it automatically reverts back to the last known good version. No human needed.
So picture this. This critical alert fires in your monitoring system. The brand new model is live, but something's wrong. Its performance is suddenly tanked, and it's violating key business metrics for both latency and accuracy. This is a code red situation.
But here's the magic. Before an engineer can even grab their coffee and open their laptop, the system has already diagnosed the problem, executed a full rollback to the previous stable version, and sent out this PagerDuty alert saying, "Hey, problem solved." How fast does this happen?
Less than 30 seconds. Think about that. The total time from detecting a critical failure to having a stable version back in production is under 30 seconds. That's faster than a person can even process what's happening. And look, this isn't magic. It's just smart engineering. It works because of a few key things working together. A super fast monitoring loop that catches issues in near real time, a simple Kubernetes command to instantly switch the traffic, and our model registry, MLflow in this case, marking the bad model as rejected. It's a whole system designed to protect the user experience no matter what.
So that's our three-part strategy, right? You've got the automation, the real-world validation, and that all-important automated safety net. This is what gives you genuine confidence when you're deploying AI into production.
We've basically gone on this journey from a risky manual process to a resilient, self-healing system. We've seen how to build that automated assembly line, run models through a tough gauntlet of live tests, and create the ultimate safety net for when, things inevitably go sideways.
And this table really brings it all home. Every single technical tactic we talked about maps directly to real business value. The automated CI/CD, that means faster time to market and fewer errors. Shadow and canary testing, that means de-risked launches and decisions based on data, not guesses. And those automated rollbacks, they're literally protecting your user experience and your revenue. It's a direct line. So, I'll leave you with this question. Your AI is live. Is your safety net automated? Because in a world where AI is making critical decisions for your business, having a safety net isn't just a nice to have, it's essential. And automating it, well, that's the gold standard.